Good morning. In this lecture, we're going to look at a hypothesis test for a proportion. In some sense, this lecture is nothing new. Once you understand hypothesis tests in general, you can do any hypothesis test as long as you know what test statistic you need to use. So let me go through this in an example. Let's say it is assumed that 30% of Americans want to ban Jell-O. I'm actually in that camp. I don't like to get political, but I'm just not so convinced by Jell-O. Okay, you think it's higher. Let's say you poll 100 people and you find that 32% like Jell-O. What do you conclude? So again, 32 definitely is higher than 30, but that just could be because of the randomness of the polling process. So you want to be able to define or somehow quantify what's the chance of getting the 32% if this really is true. For this test, let's use an alpha level again, or a significance level of 0.05. So first step is let's mathematize this thing. So H naught, well, what are we testing? We're testing a proportion. That's what the 30% is. So we're testing that P is 0.3. The alternative is that P is bigger than 0.3 because that's what you think. We have n equals 100. We have that our P hat is 0.32 because that's the sample proportion. And we have that alpha is 0.05. Again, once I have this information, it doesn't really matter what I'm testing. It's really just this stuff which will help me come to a conclusion. The test statistic in this section is, well, I actually don't need to tell it to you because we've seen it already. We've seen it when we were looking at confidence intervals. It's just P hat, the sample proportion, minus P over the square root of PQ over N. Here I'm using the Bernoulli on a given observation. This is its expected value. This is its variance. Okay, so let's compute this. P hat is 0.32, so our test statistic is going to be 0.32 minus 0.3 divided by the square root of P, which is 0.3, times Q, which is 0.7, over N, which is 100. Okay, so let me do this computation. 0.3 divided times 0.7 divided by 100 in square root. Okay, let me 1 over that and multiply it by the 0.02, 0.32 minus 0.3, and we get 0.4364. So question, is that a probability? Hopefully you said, no, that's not a probability. That is a value on the z-axis. That's the value there. So with an alpha level of 0.05, that tells me that my, let me actually sketch in the, let me not do it like this. Let me sketch in my critical region. With alpha equals 0.05, we could do inverse norm of 0.05. And that'll actually give me the negative of what I want because it's the inverse of the CDF. And we get 1.645, just as we got last time. So looking at our picture, would you reject the null or fail to reject the null? So if we said you would fail to reject the null, so fail to reject the null, because 0.4364 is close to 0 in terms of how we define it. 1.645 is far from 0. Let's report the p-value. And again, without doing any sort of computation, though, you know that the p-value here has to be greater than what? Well, hopefully you said it's got to be bigger than 0.05 because this is my critical region. This has an area of 0.05. So just by the geometry of it, that probability, the stuff to the right of 0.4364, is going to be bigger than 0.05. Okay, so here again, we could do our normal CDF from 0.4364 to some large number. Let me call that 10. So this is normal CDF from 0.4364 to 10. And I'm getting out 0.33. So that is the associated probability. All right, so that's all there is to it for proportions. It's the same process. And in fact, for those of you who go on to take 342 or take some other more advanced probability class, you're going to see that every single hypothesis test is the same. The challenge is figuring out what scenario you're in. So for example, you have to recognize, oh, I'm setting a proportion. So I need to use a proportion-related test statistic. Or I'm looking at a mean, or I'm looking at a difference of means, or a variance. That's the only challenge. Once you understand the conceptual framework of the hypothesis tests, that doesn't change from test to test. All right, that's all I have for today. So I hope you enjoyed the lecture, and thanks so much for listening.